All right, we're back for some more problem solving. You're going to need your books. Page 431 and 32 is where we're going to focus our work today. You also can get a calculator, so if you have one handy, grab it, and let's get started. So it says on number 9 that a block of wood measures 4 5/10 inches by 3 5/10 inches by 7 inches. What is the volume of the block of wood? So the first thing I want to do is just draw this. Although the dimensions are given for you, I just want to draw it so that you remember how it is that we deal with volume. So a block of wood is probably a rectangular prism, something like this. And it says that we have 4.5 by 3.5 by 7. Well, I think this is probably my 7 inches. Let's call this 4.5 inches, and then our height 3.5 inches. Now, when the dimensions are given generically like this, you don't know which of those measurements goes with what dimension, but so I drew it just sort of match my picture. So to find the volume, we are going to measure length times width times height. Right? Now, let's think about why we do that. And we talked a little bit about this yesterday. That length times width is really giving you the area of the base. So if you think about this, because it is a three-dimensional object, we're finding this bottom layer is 4.5 by 7. So let's go ahead and multiply that on your calculator. 4.5 times 7 is 31.5. And that would be 31.5 square inches because it's an area measurement. But volume then says, well, if I have 3.5 inches in height, we just keep stacking that 31 5/10 on top of each other. So we're going to multiply that times 3.5. And again, use your calculator and you get 110 and 25 hundredths for your volume. Now, volume is a cubic measurement because it's a measurement of a three-dimensional object. So we're going to write this as inches cubed, like that. Okay? All right, number 10. A restaurant buys a freezer in the shape of a rectangular prism. The dimensions are shown. What is the volume of the freezer? Well, this is a fairly simple one because, again, they give you all the dimensions that you need. All you have to do is plug them into the formula. And the formula is volume is equal to length times width times height. Length is 72.5. Width is 24.5. And height is 36 inches. Go ahead and put that in your calculator and see what you get. The correct answer is 63,945. If that's what you get in your calculator, you've done it correctly. Now, we remember that this is volume, so we have to include the correct unit of measure, which are cubed inches. Inches cubed. All right, let's look at number 11. Rectangular prism A measures 6 inches by 4 inches by 5 inches. Rectangular prism B's dimension are twice that of prism A. Find the volume for each prism and how many times greater is prism B's volume as prism A's volume. This is a great problem to draw. So let's do that. We need 2 rectangular prisms. One is obviously going to be larger than the other. This is A and this is B. So let's label the dimensions that we're given. So we have 6 by 4 by 5 inches on prism A. So 6 inches, 4 inches, 5 inches. Okay? And we know that prism B are twice that of prism A. So if prism A has a length of 6 inches, this would be 12 inches. A width of 4 inches would be 8 inches here. And a height of 5 inches would be 10 inches here. Now, let's go ahead and calculate the volume for each of those prisms. All right, so you should have gotten for prism A a volume of 120 cubic inches and for prism B 960 cubic inches. So those were the first 2 parts of the problem, but then the problem asked how many times greater is volume from prism B than prism A. So you could take the 960 and divide it by 120 and you get 8 times greater. Now why is it 8 times greater if we just double the dimensions? Well, we doubled the dimensions 3 different times. We doubled it here, times doubling it here, times doubling it here. 2 times 2 times 2 is 8. All right, we're going to skip number 12 and go on to number 13. A company is designing a juice box. The box is in the shape of a rectangular prism. The base of the box is 6.5 inches by 2.5 inches, and the box is 4 inches high. If the juice fills 90% of the box's volume, find the volume of juice in the box. You know how there's always some extra space in a container of food or drinks? That's what they're talking about. So let's first find the volume of the juice box, of the entire box. So a juice box probably looks something like this. And we know its volume is, or its dimensions are 6.5 inches here, 2.5 inches here, and 4 inches in height. And we know that volume is length times width times height. So all we have to do is multiply these 3 values. Go ahead and do that, and let's calculate the volume. Okay, so you should have gotten 65 cubic inches as the volume, but the problem says that only 90% of the box is going to have juice in it. So if you take 65, the volume of 65, and multiply it times 90%, that will give you the volume of juice in the box. So how do we do that in a calculator? Well, 90% is the same as 9/10, right? So we're going to take the 65 that we calculated as volume and multiply that times 9/10, and that would give us 58 and 5/10, and that would tell us that is the cubic, the amount of cubic inches of that container that has juice in it. 58 and 5/10 cubic inches. Okay, so number 14 is a good problem. And this may be some terminology you've heard in science class, but density is the amount of mass in a certain volume of an object. To find density in grams per cubic centimeter of a substance, you can use this relationship. Density is equal to the mass divided by the volume. Okay, so we have a gold bar that is 16 centimeters by 2.5 centimeters by 5 centimeters, and it has a density of 19 3/10 grams per cubic centimeter. We're trying to find the mass of the gold bar. So the first thing we need to do is, let's go back to what we know, is that density, I'm going to use a capital D, is equal to the mass divided by the volume. Okay, we know the dimensions of the gold bar, and we know the density of the gold bar. So we're trying to calculate the mass. The mass is the unknown. Okay, so the problem says that the density is 19 3/10. Mass is what we're trying to find, and volume is the same as length times width times height. So we can, for where volume is, we could replace that with 16 by 2.5 by 5. So let's go ahead and calculate the volume using your calculator. 16 times 2.5 times 5 gives us 200. So I'm going to replace this with 200. Okay, so now the question is, how do we get this? So remember yesterday how I said if you're not sure how to calculate an unknown, sometimes finding easier answers make it simpler. So what if we had 20 is equal to m divided by 2? What would we do? Well, how do we get 20 by dividing something by 2? You would multiply 20 times 2 to get 40. 40 divided by 2 is 20. So by multiplying this number times this number, we will get this number. So 19 3/10 times 200 is what you need to do there. And you should see that the mass is equal to 3,860. And mass, the unit of measure here is grams. So your assignment today is to complete problems number 15, and then on the next page, number 16, which has 3 parts to it. Okay, and then check back tomorrow, and I will provide you with a video explaining these answers. Okay, good luck. Bye-bye.